So with this exercise today, I'm going to take PEDs from several different soils, similar to the ones that we've just examined for soil texture, place them on this chart, and determine the hue, the value, and the chroma, or the Munsell soil color notation for that particular soil. The first sample, it doesn't really make any difference what size of PED you use. You want to use one that is appropriate for the chart. This particular soil is fairly dark in color. So the first thing I'm going to try to do is to match up the page that it's on. This particular page is the hue. All soils on this page are hue 10YR. So I placed this. One of the important things to remember if you're utilizing one of these Munsell color charts is to use the protective acetate sheet that comes with that so you don't start getting soil samples on your color plates. If I place this onto this color chart, I see that I'm probably in the right hue range. I'm not up in here where I have a much higher value or numerical number for value, but I'm more down into this range on this particular value row. Now, if I were to start on the wrong chart as an example, let's go back one chart previous to this one. If I go back to this chart and compare the PED that is in my hand with this particular chart, one of the things that comes out to me is that I'm probably in the wrong hue page. In the wrong hue page because this soil is a little bit darker in color than what I have on the 7.5 YR chart. So I don't see anything that matches up very well, so the first thing to do is to identify the right color chart or hue chart to begin with. So for this one, I've determined that chart to be 10 YR. As I look across, I believe it's in this value range of 4, and I believe it matches up best chroma-wise with this column of 2. So for this particular PED, we will call this soil a 10 YR 4/2. 10 YR is the hue, 4 is the value, and 2 is the chroma. What does this all really mean? Well, if we look across on the opposite page of this chart, we'll see that each of these soils has been given a color name based upon groupings or where they occur on the chart. So for the hue, 10 YR, the value of 4, and the chroma of 2, this particular soil, by common name, or soil Munsell soil color notation name, is called a dark grayish brown. So that is the procedure we would use to determine soil color based on the Munsell system. Now, if I look at sample number 2, upon initial observation, sample number 2 appears to be much lighter in color than sample number 1. Yet it still has a hue value that's going to fall within this page of 10 YR. I'm probably going to be further up the chart, meaning that I have not quite as dark a soil, but I have a lighter soil. As I read across this chart and I try to match them up, see that I have a very light soil. It actually matches up the best with this particular color plate right here. So I'm going to be hue 10 YR again, value 5, because everything in this horizontal row is value of 5. Chroma would be 6. So for this soil sample number 2, we have a hue of 10 YR, a value of 5, and a chroma of 6. When I refer to the opposite page, this falls into a yellowish-brown category, or yellowish-brown based on name. You can see that 5-4, 5-6, and 5-8 are all three of these in this particular end of that value range are called yellowish-brown. Soil sample number 3 is the one that we did texture on as the last example. It's the one that had quite a bit of accumulated lime in it. Now, if we look back in our chart of the same range here, we see that there, as we go up the chart or increase in value, that we do have quite a bit of more of this whitish gray occurring in those particular samples. So if I look at this particular sample, remove a PED from the pan, I know that I'm not going to be down in this range at all. I'm probably going to be up here closer to the upper left-hand corner of this particular chart. Now there's going to be some variation here because lime does not accumulate evenly within these PEDs, so you'll have some areas that are lighter than others. But as I look at this, it really matches up the best with the color plate that I've laid it on right here. So my hue is still the same, 10YR. My value, in this case, would be 7. And my chroma would be 2. This would be referred to as a light gray Munsell soil color. I'm going through this exercise fairly quickly. I don't want to indicate that soil color is not an important property. It can indicate to us some things that have happened or are happening at the present time in the soil, but it is not a characteristic that we place great emphasis on when examining soils in the field or laboratory, either one. It does not hold the same degree of importance as the other two characteristics, physical characteristics we're looking at today, the soil texture and the soil structure. The last sample that we'll examine in this laboratory today is also a soil that is much darker than the previous two. It looks similar to soil number 1. This particular sample, we remove a ped from the pan and place it onto the page. We can see that we're going to move down the page quite a ways. It's a fairly dark soil. Move down into this range. Once again, soil color, or the color of these peds in relationship to these plates, is a matter of interpretation. Not all people see color the same. There's quite a bit of variables there. I see this particular sample as falling somewhere between this plate and the one below it. If we call it this plate, we're back to what we were on sample number 1, a 10YR 4-2. Sometimes when I'm doing this and you get honed in on one particular page in the color chart, it's good from time to time to refer back to other pages, nearby pages, to see if we're still in the right range or not. Now, you could probably also interpret this soil as being one that fits onto this page. One of the things I find wrong with this page is that there's a little bit more lightness or yellowing in the brown here instead of graying. And this particular soil fits more over on the 10YR hue page than it does on the 7.5YR. So just as a cross-check, I've done that, but we really fit better onto this page, the 10YR hue. This particular one, value of 4, chroma of 2. It's like the first sample we looked at. We look back and refer to that, and we're back to the dark grayish-brown color. So when doing soil color, it's a matter of interpretation. The Munsell system can get us within a certain value range and hue and chroma range. That will vary based on moisture content for the same soil at a given point in time. Here today, to try to compare these soils at the same moisture content, we have air-dry samples.
So we are in a field called Crabtree South, sand and gravel field, and we've had a bit of a drainage issue. So we're putting in another travelling main here. This is a 6-inch pipe that Clive Spencer is putting in here for us, and we're going to go through just past that hedge and then connect into the lateral drains which run up just behind the hedge over there. So that should drain quite a lot of the field just above this hedge, which is game cover and is due to go into spring barley this year. And it's very, very wet down through here. These drains have really been struggling to cope with all the water that we've had this year.
When rainfall hits the Earth's surface, one of two things can happen. Water can run off the land, or often, with the help of sound land management practices, water can move into the soil to be an environmental positive rather than a negative. The soil itself has an influence on whether water runs off or moves into the soil. Here's a brief explanation of how and why soils transmit water at different rates, and why you should check a soil survey when you're concerned about runoff, flooding, leaching, or other environmental hazards. Water movement in the soil is strongly influenced by soil particle size, or texture, as well as structure and pore size. Soil texture is the relative amount of sand, silt, and clay-sized soil particles. Sand particles are the largest, silt is intermediate, and clay is the smallest. Water moves more quickly through the large open macropores found in sandy soils than the smaller pores of silt, or the much smaller flat-shaped micropores in dense clay soils. Soil structure also impacts water movement. Water moves more quickly downward in soils with granular structure than a soil with platy structure that forces a longer indirect path downward. Other structures include prismatic and subangular blocking. Water is nearly always moving in the soil, and it can be in any direction simultaneously. Gravity is the dominant force that moves water downward. Restricted soil layers of compacted soil or bedrock are among the reasons water moves laterally. Capillary action, the attraction of water into soil pores, can move water in any direction. Gravity is the primary water-moving force in saturated soils, while capillary actions are the primary forces in unsaturated soils. Capillary force is greatest in soils with small pores. Water moves more slowly through these soils. Well, that's a brief explanation of what a soil scientist calls saturated hydraulic conductivity. In simpler terms, the capacity of a soil to transmit water. Since downward moving water carries nutrients and can carry contaminants into underlying groundwater, soil percolation rates are important in choosing sites for septic fields, landfills, and other waste burials, as well as underground storage tanks and other uses. The information is critical for planning soil drainage, irrigation, and tillage systems, as well as other crop management practices. Get the information you need on water movement rates and other soil properties from a soil survey of your area on the web at www.soils.usda.gov.